Grade 12, Trigonometric Functions, Mathematics, Exam Questions, November 2020, Paper 2, Question 5 from DBE. Okay, let me get the question again. Question 5 from November 2020. This is the question. Okay, question 5. So, question 5 from November 2020. You are given two graphs. Okay, the graph of f and the graph of g. Okay, the graph of f and the graph of g. Okay, you can see that the two graphs. Now 5.1, write down the period of g. 1 mark. Okay, write down the period of g, the period of this graph. You are given the equation. So let's see this information. The amplitude and period of a sine graph. Okay, when you are given the equation of a sine graph with all the parameters, as in this case, to find the amplitude, you are going to take the absolute value of what you have in front. Okay, the amplitude is equal to the absolute value of what you have in front. Okay, absolute value, meaning you are going to take a non-negative value. Okay, the same when it is a cosine graph. The amplitude is equal to absolute value of what you have in front. When it is a 10 graph, you don't have an amplitude. Okay, for 10, you don't have an amplitude. Okay, I'm going to make a video in which I explain all these parameters. All these parameters, A, B, P, and Q. For the period, you are going to take 360. When it is sine graph, you are going to take 360 over B. Okay, over B. When it is sine graph, even when it is cos graph, you are going to take 360 over B. Okay, for sine and cosine. When it is for 10, the period is going to be 180 over B. So let's write down the period of G. 1 mark. This is the equation that you are given. G of x is equal to this. Okay, sine of x plus 30 degrees. Okay, let's write down the period. So the period of this graph, the equation is given, is equal to, this is a sine graph. Okay, G of x is equal to sine of x plus 30 degrees. Okay, a sine graph. So the period is equal to 360 over B. What is B? Can you see what is B? In this case, B is equal to 1. There is an invisible 1 in front of this bracket. This is going to be over 1. And so the period is equal to 360. Now 5.2, write down the amplitude of f. You are given the equation of f, which is a cos graph. This is the graph of f. Okay, so this is the equation that you are given, right? This is the equation that you are given, the equation of this graph, the graph of f. Now the amplitude is equal to amplitude for cos graph and sine graph. The amplitude, you are going to take the absolute value of what you have in front. Okay, so the absolute value of this is going to be 1 over 2, a non-negative value. Okay, a non-negative number. Okay, let's move on. Now 5.3, okay, 5.3, determine the value of this f of 180 minus g of 180. Okay, 1 mark. I can close this. So you have to determine f of 180 minus g of 180 is equal to, this is what you are given. Okay, you are given the graph of f and the graph of g. You can see when x is equal to 180, you are there. Okay, so you are going to take 180, you plug into f, minus you plug 180 into g, and so you are going to have your answer. So the question, what the question is asking for, you can see f the graph of f is above when x is equal to 180, and you can see g is below when x is equal to 180. So if you understand the question is actually asking you for the vertical distance when x is equal to 180. Okay, f minus g, right? F minus g, you have to find the vertical distance. Okay, so let me show you. The question is asking for this vertical distance, the vertical distance when x is equal to 180. The simplest thing to do is to plug 180 into f minus you plug 180 into g, and you have your answer. Okay, so let me do that. Okay, I can use a calculator. So we have the equation of f. Okay, this is the equation of f, and we have the equation of g. Okay, this is the equation of g. So we plug 180 into f. Okay, this is the equation of f. Okay, let me close everything into the bracket like this. Okay, now I have cos of x. So I'm going to plug 180 wherever I have x. Okay, I close this bracket and I close this bracket. Okay, minus g of 180. I'm going to plug 180 into g. Okay, so this is g. Let me close everything inside the bracket. Okay, so sine of this x, I'm going to plug 180 wherever I have x. Okay, plus 30. I close this bracket and I close this bracket. Now I'm going to have 1. Okay, so this distance is equal to 1 unit when x is equal to 180. Okay, let's move on. Let me get the question again. Okay, question 5 from November 2020. So now use the graphs to determine the values of x in the interval x element of from 0 degree to 180 degrees. You have square brackets, for which 5.4.1 f of x minus 10 degrees is equal to g of x minus 10 degrees. Okay, 1 mark. So 5.4.1, determine the values of x when f of x minus 10 is equal to g of x minus 10. Let me close this. So what you have to understand with what you are given, when two graphs are equal to each other, this is going to happen at the point of intersection. In this case, you can see you have the graph of f and the graph of g. So this is the point of intersection. You are given the coordinates. Okay, so at this point, the point of intersection, at this point, f of x is equal to g of x. So what is going to happen? The two graphs are going to move by 10 units to the right. When it is negative, to the right. When it is positive, to the left. Okay, negative is always associated with left, but you are going to do the opposite. Negative, right, positive, left. Okay, you do the opposite. Okay, so let me show you. 10 units to the right. Okay, so this point of intersection is going to shift 10 units to the right. Okay, so you are given the coordinate for now. Okay, you are given the coordinate. If this point shift x is going to be 140.9. Okay, so x is equal to 140.9. Okay, question 5.4.2. Let me get the question again. Question 5 from November 2020. Okay, this is the question. Question 5 from November 2020. Okay, now 5.4.2. Okay, use the graphs to determine the values of x in the interval x element of this interval. Okay, from 0 to 180 degrees. Okay, you have square brackets for which this is greater than or equal to 1. Okay, determine the values of x for which this is greater than or equal to 1. 4 marks. Okay, this is what you are given. You have to determine the values of x for which this is greater than or equal to 1. Okay, this is what you are given. So, you have to use the two graphs. Okay, the graph of g and the graph of f. Okay, so we are given g of x. Okay, g of x, this is g of x, and f of x, this is what you are given. And you are given the two graphs. Okay, I can close this. So, determine the values of x for which this is greater than or equal to 1. The two graphs, these are the equations for the two graphs. Okay, with what we are given, you can see this does not look anything closer to this, to any of these equations. So what you can do is to rearrange or manipulate this and try to end up with any of the equation. Okay, try to rearrange this and try to end up with any of the equation that you have. You can see sine of x plus 30 degrees. I can try to divide by square root of 3 throughout so that I can cancel this because I've got an invisible 1 in front of this. Or you can divide by 2. Can you see? You have 1 over 2 in front of cos, but here you have 1 in front of cos. You can divide by 2 so that you have 1 over 2 in front of cos. You can divide by 2 throughout. So let's try to divide by 2 throughout. Okay, you are going to have square root of 3 over 2 sin x plus 1 over 2 cos x greater than or equal to 1 over 2. Okay, divide by 2 throughout. You have this. Now, when you see this, what comes to your mind? You can see you have sin x on this side, cos x. Okay, sin x plus on this side cos x. So what you have to think about is the compound angle identities. Okay, compound angle identities. You can see this on the information sheet. I'm going to make a video in which I discuss compound angle identities. Okay, so you can find this on the information sheet. So let's carry on. Now this and this, you have special angles. Okay, cos 30 degrees is equal to square root of 3 over 2. And sin 30 degrees is equal to 1 over 2. So you can change this to this. Okay, this, because this is equal to this. Okay, special angles. I'm going to make a video in which I discuss special angles. Okay, and you carry on. You have sin x plus, and this can be substituted with this. Okay, sin 30 degrees. You carry on. You have cos x greater than or equal to 1 over 2. Now, can you see this is the same as this? Okay, let me write this there plus this side. Okay, so that you can see. Can you see? You have sin alpha plus cos alpha, okay, sin 30 degrees plus cos 30 degrees, okay, cos beta plus sin beta. Can you see? Cos x plus sin x. You can change this to sin of 30 plus x. Can you see this? Can be changed to this. Okay, sin x plus 30 degrees or sin of 30 degrees plus x. Still the same. Okay, greater than or equal to 1 over 2. So this is equal to this because of compound angle identities. Okay, I'm going to make a video in which I discuss compound angle identities. Okay, now you have this. You can see now this is the graph of G. Okay, so you are going to use the graph of G to answer this question. Okay, where is the graph of G greater than or equal to 1 over 2? So to find x, let's use equal for now. Okay, I'm going to write like this. Equal 1 over 2. I'm using equal for now to find x. We are going to find out the values of x when this is greater than or equal to 1 over 2. For now, let's use equal. You have x plus 30 degrees. Okay, x plus 30 degrees is equal to arcsine of this. Use your calculator. X is equal to arcsine. You press shift. Sin, you have arcsine of this minus 30. You take 30 to the right so that you can solve for x only. Okay, take 30 to the right minus 30. So you have 0. Okay, so 0 degrees. Okay, now you know at 0 degrees y is equal to 1 over 2. Let's see that on the graphs. Okay, this is what you are given. So this is the graph of G and the graph of F. Okay, this is the equation for G and this is the equation for F. Okay, so when x is equal to 0 degrees, y is equal to 1 over 2. Okay, try to plug 0 in there. You are going to get 1 over 2. When you plug 0 in there, you are going to get 1 over 2. So this is 0 degrees and y is there, 1 over 2. So when y is equal to 1 over 2, x is equal to 0 degrees. Okay, you can find other x values which can give you 1 over 2 as y. So to find that, you are going to draw a horizontal line. Okay, when you draw a horizontal line, you are going to see that this point, the y value is equal to 1 over 2 and the x value is in between 90 degrees and 150 degrees. Okay, so because of symmetry, you are going to find out that this is equal to 120 degrees. You are going to see that if you plug 120 there, y is equal to 1 over 2. So for x equal to 0 degrees, y is equal to 1 over 2. Okay, y is the same as G, the graph of G. When x is equal to 0 degrees, G is equal to 1 over 2. Okay, when x is equal to 120 degrees, G is equal to 1 over 2. Okay, or y is equal to 1 over 2. This is G. Okay, what about when G is greater than 1 over 2? Find x. Okay, when G is greater than 1 over 2. This is greater than 1 over 2. Okay, let me show you. This part. G is greater than 1 over 2. This part. And this G is less than 1 over 2. We are interested in g greater than 1 over 2. We are interested in this. You also have x equal to 120 degrees. Okay, x equal to 120 degrees is going to give you g or y equal to 1 over 2. So you are going to have this. This answer can also be written like this if you want to write in interval notation. Okay, so let me erase this. Okay, so we are done with question 5 from November 2020. Until next time, I will talk to you soon.